All right, we are live. Welcome back, everybody, to Bitovi's free weekly JavaScript training. With me, as usual, is Alexis Abril, now in India. How's it going over there?
Pretty well, pretty well. Dig the food.
Yeah, today we're going to be talking about elements and DOM elements, and building our own version of jQuery that manipulates those DOM elements. So I think we just get right into it today. I think we've got like 3 or 4. With me, as usual, is Alexis Abril, now in India. Whoa. How's it going over there? I am watching myself. Okay, closed. All right, let me share my screen and get started here. Future is now. It is working. Awesome. Okay. Can you see my screen, Alexis? Let me make sure you go full screen here.
Sure can.
Awesome. Actually, tell me in 2 seconds. Now can you see my screen?
Still good.
Awesome. Okay, so elements. Again, we're working towards building our own tabs widget from our own version of jQuery. And we're going to eventually add all of these methods that jQuery supports that let us find and manipulate elements. Also listen to events, which I don't think we're showing here, but we will add jQuery's bind and unbind methods. So the first thing that you're pretty much always doing with jQuery is using it to find elements in the page. And we're going to talk about what the DOM supports that lets you find elements in the page. So again, when I say the DOM, I mean the document object model. We talked about this in the first lesson, that when people think of JavaScript, often they think of the DOM, the thing that lets you manipulate HTML. But JavaScript is a language, and the DOM is an interface that lets you manipulate HTML. And the DOM provides methods for also finding different elements, listening to elements, and as I said already, changing what those elements look like or how they're related to other elements in the page. So the DOM allows you to, the DOM is typically, kind of sometimes the starting point of the DOM, you could think of it, is this document object that's kind of the, represents all of the elements that are currently in the page. So this document construct has different methods that let us find different elements in the page based upon something. So we're going to take a look at what these functions do. So the first one, which most people are probably very familiar with, is document get element by ID. This, if you give it a value, finds all elements in the page that have an ID property that matches what that value is. So if I wanted to get this UL element, which has ID equals breeds, if I wanted to get it, have it access to that element in particular to do things to it, I could call document get element by ID and pass it breeds. And that's what would return this element in the page. The DOM also provides a get elements by tag name. This finds every element in the page that matches a particular tag name. So in this case, I'm finding all elements that are LIs. So if my document looked like this was everything in the document, it would give me 3 LI elements. Now what's returned here looks like an array, acts like an array, but is not an array. It is a node list, which has kind of special behaviors. One interesting behavior of a node list is that if I were to add a new LI to the page, which we'll see how to do later, if I were to add a new LI, this array would immediately, like, magically have that new LI in it. It's really a live array of elements that match LI. Document get element by class name is pretty similar to the get elements by tag name, where instead of matching elements tags, it matches elements class attribute. So in this case, if I want to find all elements with the word contact inside of its class name, I could use document get elements by class name, and this returns a node list as well, a live array of all elements that contain that class name. Now, one important thing that I don't show here, but I want to talk about real quick, is the fact that this will match elements. It's not an exact match, meaning if I had contact and box or something like that, this would still match this div. This would still return the div element. It's not, I wouldn't write contact box. I don't need to write contact box. I write any word that will be matched in here. So it's if it has this kind of name inside the class. It uses spaces to separate different names. So with this, let's just take a quick brief aside about when to use IDs. When to use IDs to label elements, and when to use class names to label elements. Alexis, how do you feel about this? When do you use which?
These days, I rarely use IDs, but I do. I don't have a problem using IDs if I know for certain that it will be a unique element on the page. And this is kind of hard when you're building reusable widgets, etc., because those will not be unique. If I know some container, maybe like a main app container will be unique, then I'll use an ID.
Yeah, that's very well put. So to kind of explain that a little bit more to people, by default, I tend to use class names. The reason is because let's say I started my app and I had a person, and I started, okay, I want a person, and maybe I'm gonna want to use jQuery at some point to get the person and do some kind of behavior to it. I want some person is clicked and then do some behavior. This is what you would write with jQuery. Is you get the person and then you would listen to the click event and you might have some code that would run. Now the problem is, let's say tomorrow you have suddenly 2 people on the page, right? You want, okay, now this page isn't showing 1 person, you want to show 2 people. Well, the problem is that you can only have 1 element on the page for a given ID. So you can't actually you can write this code, but this down here won't listen to both people being clicked. It only listen to the first person being clicked, or maybe the second person in different browsers. That's why it's best typically to use class names and then find that find those elements that you want to add behavior to by class name. It's mostly because IDs introduce a global, and those are things you tend to want to avoid in programming. This leaves you safer for modification later. If your application changes, you're not going to have to change a bunch of code to deal with it. Okay. So the get elements by class name we talked about. Okay, so now let's talk about document query selector all. What this does is you pass it a CSS selector, like something you would normally write in CSS, and it will find all elements in the page that match that CSS. And this does get returned, I believe, as a real array. It is not live. That would be cool if it was, but it's not. So this is very useful if you're going to build your own version of jQuery, hint, hint, query selector all. So that's the first thing that we're going to do, is we're going to create a function named $, that takes a selector as an argument, selects elements from the DOM, and returns an array-like object. All right, so this is our dollar function. It takes a CSS selector as an argument, and what we want it to return is something that looks like an array. So it's got a length and it's got indexed properties, and each one of those indexed properties matches one of the elements in the DOM. And breeds is going to be an instance of dollar. And this hint is a kind of a shortcut that allows you to add a bunch of items to some object that isn't an array, but it makes it so it has like a length and it has a, well, you have to set that to a length. Makes it so it has like a breeds 0, breeds 1, breeds 2 property with pointing to each item that is in items. So that's our first exercise. What I would do right now is, if you're going to try to work through it, which I strongly suggest you try to do it, pause the video now, and then Alexis and I are going to start building our version of this right away. And if you want to follow along with what I'm building, we have this, JS bin that I posted in the Gitter room. It is PoWipe2. I don't know, that's a funny name to me. And it's got the methods that we worked on from last time filled out. Hide my HTML. And it's got places for the dollar function, which I'm going to implement right now, and the HTML val text and find function. So with this, you can get started on your own if you want to pause the video, working on it in here. Otherwise, I'm going to get started filling out the dollar function. So this dollar function should work exactly like jQuery works, or very similar to how jQuery works. The first thing I need to do is get the elements in the page that match this selector, right? And this selector can be just like you're used to with CSS, right? You might have sometimes have said like, oh, I want all links that are like important, or like you know, all links that look like that are you know, navigation links to, you know, be color green. Right? This is a CSS selector. Everything you would write up in here is a CSS selector. So I want to use that CSS selector to get some elements. Is that the link to watch? Oh, now it's changed.
Because you edited it, so I just gave him a watch.
Oh, okay, yeah.
Did
Okay,
you ask me a question at the same time?
BAFAMO/latest/watch. Thanks, Alexis. So I'm going to use the. I'm going to use query selector all to get all of those elements. Okay, so now I've got an element, but you remember that this dollar is going to be called with new dollar, and then something like, you know, ul.nav or something like that, and then maybe li's. If we wanted all li's inside of a ul that had class name nav, we're going to call it like this. But the important thing that I want to stress is we're calling new dollar, because what we want is, what this thing returns is a jQuery-like object. Eventually, I want to be able to call $li_HTML. I want to be able to read the HTML from the first li, right? But this HTML function is on this li. The reason it's on this li is because we use the new operator to call dollar. And dollar, as we'll see, has the HTML function added to its prototype. So if you remember back to the prototypal inheritance, anytime the dollar function is called with new, the HTML val text find methods will be on its proto chain. So hopefully you can see how we're starting to put these concepts together to good use by making our own version of jQuery. So what we need is this dollar, it's called with new, but we want not only to have its HTML function, which will happen by default automatically, we want $li0, that to be an li element. So we can't just simply return, we first can't just return element, because by returning element here, we're not returning what this is. We're not returning that instance of dollar, so it won't have the HTML function. But it would, of course, have 0. So what we need to do is, I'll do it kind of the most easily understood way, is I could go through every property in element, or every item in the element. So I'll create a little loop here. I'm going to go through every node in the element. And what I'm going to do is I'm going to stick that on this. Now you probably all are familiar with being able to do this dot, foo equals some value, add our arbitrary properties to the instance that we created. But what I want to add is a property named 0, not a property named foo. So I want to actually add the ith property, which would be 0 at first. I want to set that to the node. So this is going to loop through and create a 0 property that points to whatever. This should actually, I'm not going to call this elements. Sorry, that's a bad name. I'm going to call them elements. It's an array of elements. I'm going to go through that array of elements and set a property on the instance that's being returned, a 0th property to point to the first element or the first node in elements. And then the second one, and then the third one, the fourth, and we'll create property 0 through length -1. And then the final thing I want to do is set this dot length equal to elements dot length. Now let's make sure that this works here. I did something wrong. Let me see what I did wrong here. I can't just run that one, can I? That doesn't work. That's too bad. Alexis, can you spot the problem? You can't immediately. So we might need to debug it. I'm going to put a debugger in here. Oh, I think it just passed. Okay, so here we have a debugger. We have our selector, unit fixture. Is that right? Oh, this is the...
Yeah, it's passing right now.
That's weird. Why was it not passing when I first did it? Huh. Weird. Okay. Let me turn that off for a second and bring this back.
Yeah, I think it's something with auto run. Historically, we haven't done well with that button.
Now let's get the debugger back in there. Okay. Ugh. Okay. It is working. I don't know why that debugger is still in there, but let me just add a new line and maybe it'll. Okay. All right. So it's passing. Okay. So hopefully this amazes you if you're watching it right now, because I even remember when I had the first realization of how stupidly simple jQuery works and how jQuery is really awesome that it's able to be like an array, but also this array with all these awesome methods on it. How to create that object is ridiculously simple. You're just you're just getting the elements back and you're just adding them as a 0, 1, 2, 3, 4 property. And that's all it takes to really make something look like it's array-like. Again, cycling back to an old training where we learned when we created our isArray-like, it's very easy to create array-like objects in JavaScript, give them a length, and then give them indexed properties. Now, in previous slides, we looked at previous lectures, we talked about how we can implement like some of JavaScript's native functionality, like new and dot operators and things like that. Now, JavaScript comes with a lot of native functionality, such as like arrays push method. Right? We can almost envision what arrays push method might look like if we were to implement it ourselves. And I'll use this. I'm going to steal this method to use it in the dollar function to make this code a little bit less. But I want to explain what arrays push might be doing, so we can see how easy it is to steal JavaScript's base functionality on our own objects. So let's take a look at what I mean by that. Array.prototype.push. If we were implementing JavaScript language itself, we might implement array prototype push as follows. First thing to know about array prototype push is that it can take multiple arguments. So it can take like as many arguments as you want, and all of these arguments will get added to the end of the array. So with that, we could do something, we can imagine array's prototype as looping through all of the arguments and adding them to the end of the array. That might look something like this. Start length equals this dot length or 0. So get the initial length of the array. And then we're going to loop through all of the arguments. That were passed. And then we're going to set the start length. So wherever the last item, the new last item belongs at length, right? The last item in the array is always at length -1. So if we go start length plus I, that's where we should put the first argument. So I'm going to write arguments. I'm going to set on the array the next item to be whatever, the next item in the arguments list. So we're going to kind of copy everything from arguments onto this as different properties. And at the very end of this, I'm going to just write the new length of the array is equal to the original length plus arguments dot length. Now you could imagine that someone implemented array prototype push to look just, this push function to look just like this. Now knowing that, and knowing that functions are just functions, and that this push function really just doesn't belong, it's just a function that can be called on anything. It just does certain things depending on, what this, it just, just calls to whatever this is and changes its length and adds index properties to whatever this is. Knowing that, we can steal that functionality by calling array.prototype.push and just calling, or actually we're gonna use apply, call that function with this, so that this in here is the jQuery instance, and we're going to pass it, the arguments are going to be the elements. I don't think you need to do the length thing anymore, too, right, Alexis? I think in some browsers, but not in all. So that, it still works. Although I did just overwrite array curl tab push. I'll get rid of that. Although I will, I'm going to copy this into the getter for now. We should probably put this up on the site. People can see it. That in getter. But let me delete that just to make sure it's working without my special form of array curl tab push, and it works. So hopefully we just, I wanted to show, there's a lot of kind of cool complexity, but I can't stress enough how important understanding how something like this works can help you so much when you become an advanced JavaScript developer. Things like this really speak to the heart of how flexible JavaScript is and what you can do with it. So I think that's why we kind of throw in all this kind of cool, tricky behaviors. Okay. So let's go on to the next exercise. The next exercise, we're going to make jQuery's HTML function. Now, with a lot of jQuery's functions, methods on a jQuery instance, allow you to get and set some value. In this case, the HTML function, if we pass it a value, it will set the HTML of every single LI to match this inner HTML here, matches HTML we passed. That's the setter form of an HTML method. Sorry, the setter form of a jQuery method, right? You pass it certain arguments, and that means things are being set on every single item in the jQuery collection. The getter form is always one less argument, in this case 0 arguments, and this is used to read the first inner HTML of the first LI in the collection. So this is pretty much how jQuery works everywhere. A setter sets every single element to set some property to some value, and a getter reads some properties first, reads the first element's property. So that's what we're going to do to build our HTML function, and we're going to use the inner HTML method that the DOM provides. So again, if you want to take a break, I would take a break, or not to take a break. If you want to try to build this on your own, pause the video now. I highly suggest you try to struggle with all of these before you look at the answer. So I'm going to implement the HTML function down here. Oops. And I want to create some space at the bottom of this just so we can have this in a nicer spot. Okay, so the HTML function, the first thing that I want to reiterate is that depending on if new HTML was passed or not, that means we want to either get or set. So naively, a lot of times people write it like if new HTML, that means some new text has been passed, then you want to do the setter. Otherwise, run your getter code. So Alexis, why is this a bad idea here?
For those watching, if you remember back to our previous lectures, JavaScript's really, you get caught up a lot with truthiness and falsiness of things. So it could be completely valid to pass in, an empty string or a 0 or null or undefined. Maybe not in this function particularly, but those will result, even though you're setting it, will result to like a false positive. In this case, it'll trigger the getter, in our case, if we passed in something like an empty string or a 0.
Yeah, so in this case, wanting to set every LI to wanting to make it so it has no inner HTML, remove every LI's inner HTML. It's actually a very common thing that you might want to do. So some people might want to be able to pass like an empty string. Well, an empty string is falsy. So in this case, your getter would run when you really want your setter to be setting the inner HTML to empty strings. Now, one thing I forgot to mention, we're right now having to call dollar with new, but we're going to remove that in a little bit, that you don't have to pass that. Where normally you don't have to with jQuery, you just call it dollar. You don't call it new. But we'll remove having to do that in a little bit. I just think it's important to show that you're creating an instance of something in the beginning. So Alexis, what is the, how do you fix that? So if we can't just see if it's, you know, if we want to call the setter as long as someone passed an argument, not if whether the argument is truthy or falsy, how do we do that?
Right. What's nice about JavaScript functions is we kind of have this meta, information available in a lot of places. In this case, we have arguments, which is our array-like object, which tells us what was passed in. And it's not a full array, so it doesn't have push, pop, slice, all that good stuff, but it does have a length property, which we can check to see how many arguments are actually being passed in.
Yeah, exactly. So we can check if arguments.length is truthy, that means it's not 0, then that means we should actually be calling the setter. So I'm going to do the getter first, which is just needs to return the first element's inner HTML. So I'm going to do that really easily. That is just going to, I'm going to get this, which is going to be my jQuery instance. It's going to be my array-like thing that has every LI in it. And I'm going to get the first item in that array. And then the DOM provides an inner HTML method. So that that inner HTML method is just returns all the inner HTML in a string format of an element. So we're just going to call that and return what that gives us. So hopefully that makes sense. And the setter, now for the setter, that has to loop through every single LI, every single item in the collection, and then set its inner HTML to whatever the person passed here. To loop through, I could do a for loop to go through everything from, I could do, for I equals 0, I is less than this dot length. I could do this, but that's lame. Because, well, we have a $each function. And I can pass it this. I can pass it the jQuery collection because it is array-like, because it has a length and has numeric index properties. And I'll pass it a function that will get called back with the index and each element in the collection. And I'm going to set the elements inner HTML to the new HTML that was returned. So that's most of it. Now, one thing jQuery does is whenever you are calling a setter form, because there's really nothing to return when you're setting a value, it always returns the original, it always returns a collection, the source collection. So in this case, it should return this. Now, if you remember $each when we wrote it, it actually returns the collection that someone passed to it anyways. And because we passed in this to $each, if we want to save a little bit of code, we can do things a little more slickly. We can return what $each returns because $each is returning this anyways. So with that, I should be able to auto run. And my HTML, I spelled new HTML wrong. There we go. I should be able to run again. And now $.fn.html works. Groovy. Okay. So let's now talk about the next exercise. Let's do that. Here's the button. So the next exercise is just like the last one. In this case, we want to be able to change the value property of input elements. So input elements have a value property, and that is what, if you look at an input element, that's the text that shows up inside of an input element, and that's kind of the text that people can change. I don't know if we have a, I can just create a new JS spin to show off what I mean. If I were to just create an input element here, let's put foo, you can see I get foo in here. This is the value. And there's a value property, so there's not only a value attribute, but that is also linked to a value property on the input. You'll notice that DOM elements, we'll talk about all about attributes and properties and things like that in a few more, but you'll notice that some attributes are kind of special, that there's also a property on the object that's linked to the attribute value. So value is both a property and an attribute on input DOM elements. A little confusing, but it'll make more sense a little bit later. But to do this exercise, we're going to implement the val function just like HTML. And here's a good place to stop if you want to do it yourself. And hopefully now you've come back and you've fixed it, and I will implement this val function. It's really simple. If you're going to just use copy and paste, which is always good when you can. Although, yeah, in this case, instead of changing innerHTML, we're going to change the value property and return the value property when we're doing the getter, and we're going to set it to the new val that was passed. Exact same type of code. So let me run that, and val passes. Cool. So does this ask to merge them? Okay, no, we don't do that one. Maybe I'll do the supplemental at the end. Okay, so the next exercise. We want to remove the need to call new when using our jQuery object. Or when calling $, right? I don't want to have to call $, with new, but I still want the same behavior as if I were calling it with new. So how can we make that happen? Now this is a really good exercise for you to try to struggle with for a few minutes on your own, try to come up with the idea of how you can make it work. Because if you can figure out how to make this work, then you really know JavaScript really well. And if you can't, no worries, that's what we're here to explain. So, Alexis, how do we do this, huh? How can we make it so we don't have to call new, but when you call $, you're still going to get returned to you an instance of $? No.
So one of the most important things when you're approaching any type of these problems is to be able to verbalize the actual problem. In this case, we always want a new instance of $. So if we think back to what the new keyword does a few things. Creates a new object, sets the proto-chain up. And this is really one of the important parts of this. What we want to do is verify whether or not this is set correctly. With our knowledge of context and the proto-chain, we can actually check this a number of different ways. We could check, we could use instance of. We could say, is this an instance of $? Excuse me. Which will check the proto-chain for us and make sure we are actually creating a new instance of $. We can say,
hold on, you're giving away too much.
Oh,
I wanted to.
Sorry.
Yeah, no worries. Because I always like to do the window thing first. You know what I mean?
Oh, yeah.
We'll think about it that way first, and then talk about the problems. So no, but what Alexa said is right. So it's useful to break down the problem. We do need a new dollar somehow created, right? Somehow the dollar function actually needs to create a new dollar. Now we could do that by doing something like, just pseudocode in here at this point, new dollar selector. But how do we make it so that, well, there's a problem that if we were to write this code right here, well, this is going to infinitely recurse because dollar is going to call new dollar here, which is then going to call dollar again, which is going to call new dollar again, and just keep going around in circles forever. So what you need to be able to do is somehow tell if new was called or not, if new was used, if this inside here is an instance of dollar. So, well, that's one way, but the other way is like, was dollar called with new? Well, if dollar wasn't called with new, we know what this probably is. This could be, this is equal to the window. Because whenever you call something with just dollar, this would be the window. What we could say is, okay, well, if this is the window, then we're gonna return new dollar selector. Otherwise, if it's not, we're just gonna do the behavior that we were doing before. So this is a way to kind of trap that. Now, what's wrong? What could go wrong here? Alexis, what do you think?
Well, if you're just using the window, it's a good question.
So think about so one thing that we do in FuncUnit, which is one of our testing libraries, is FuncUnit has its own version of jQuery. We have FuncUnit has its own internal version of jQuery. We use alias like this. We say, okay, the dollar function, by the way, and jQuery are the same thing. So really, jQuery kind of code looks like this. What we do in our code is say, okay, well, FuncUnit.dollar is equal to dollar. And then all of FuncUnit's code does stuff like this. Like if you look at FuncUnit dot, it has its own prototype dot, I don't know, click. It has its own click function. It might do something like FuncUnit dot dollar, click or something like that, right? There's some code in here in FuncUnit that's all it's doing calling FuncUnit.dollar because that's where it keeps its version of jQuery. Now, if you did this, you're suddenly using the dot operator to call this function here, and this would not be the window, it would actually be FuncUnit. So although this would probably work in like 99% of use cases of jQuery of what people are doing with it, it doesn't work in 100%. And I always like it if things work 100% of the time, because then people don't have to find weird, crazy bugs. So the way to fix this is instead of just checking how the function was called, like let's just make sure that it was called with this is an instance of dollar. So I can say that if this instance of dollar, we learned about how instance of works. I'm going to say if it's not an instance of dollar, then we're going to force the issue and pass selector to calling new dollar. So this should work. Yay. Okay. So next exercise. is text. So we want to add, just like we added val in innerHTML, we want to add a text method that gets and sets the text of an element. So let's take a look at why this can be a little bit tricky. Now, it actually can be quite easy now with modern browsers, but I like to make things difficult if it means it's a good learning experience, and these methods were the only methods that worked anyways if you were using really old browsers. So first, let me explain why getting the text might be a little tricky. And I'm going to do this in a different JS bin. And I'm going to create a UL here. I'm going to create some LIs in it. All right, so here we have a UL with 3 LIs that you can see over here. Alexis, how many child elements or how many child nodes do you think this UL has?
Oh, let me see here.
If you didn't already know.
1, 2, 3, 4, 5, 6.
No,
I'm gonna say 9.
If you didn't already know. How many would you, if you didn't already know?
Oh, 3.
Yeah, 3. Yeah, you would think it has 3, but how many does it really have?
9.
7, I think. Right? No, am I wrong? Oh, 9? It's gonna
You might be right.
It's gonna be
The
1
current.
here. Well, let's look. Let's look. We can easily inspect our element. We can click on the UL here. We can check on. Wait, where is that? What am I missing here? Is styles computer event misuse? Oh, there's properties. There you go. And I can check on the UL, and it has child nodes, and it has 7 child nodes. What? Why does it have 7 child nodes instead of 3? Well, it's because text nodes are always taken into account with elements. So this UL has a text node right here. Its first child node is actually a text node that's going to contain a line break and a tab. So we can actually see that in here. If we look at child nodes, it's got a text node, and we can see that it's like its node value. This means a line break and then some space, which is probably a tab. And then it's going to be the LI element, which you can see here. Then another text node, then an LI element, then a text node, then an LI element, and then finally a text node at the end. So to get all of the text of this UL, the way to do it would be to recursively go through every child node of the UL and see if it's a text node. If it is a text node, add that to an accumulator that contains all of the text nodes. And then if it's not a text node, like an LI, then recursively walk through that LI to find all text nodes inside of that and add that to the accumulator. So that's how you would get all text nodes. To set a text node is actually really easy. You can actually just use the document.create element, or sorry, document.create text node, pass it a text node, and add that to the UL, and that will, and then you also have to remove all the other children, but you can do that with innerHTML. So that's the exercise, and those are kind of the hints for the exercise, which you can see here. So I'll leave this up for another second. So try to do this, and then I'm going to start with the answer. I'm first going to actually do the setting because I think it's definitely easier, and then I'll do the getting. So let's start. So text here. So the first thing I'm going to do is the same kind of getter setter logic. If arguments dot length, and we're in the setter territory. Otherwise, we're in the getter territory. Now, for a setter, we want to loop through all of our elements. Actually, before that, what I'm going to do, before I loop through, the first thing I want to do is I just want to clear out. So I'm setting text. Actually, let me start one more simple thing. Now you'll notice here that I can like put a left caret, and then it shows up as like a, you can see it in the page. But I can't just write like something like what I might want to be able to write someday. What you might want to be able to show people is things that look like tags. Meaning, I might want to be able to write some text in here that says, my favorite element is blink. Now you'll notice that I wrote out my favorite element is blink, but this created a blink tag. Okay, not an escaped version, right? So this li has a child, which is a blink tag. What you really want is to be able to go less than and greater than, and get it to show up. What jQuery's text method does, it allows you to set the text of a li or any other element to any string like this. It'll allow you to actually set it to the string with some things that look like elements inside of it, but it will properly escape that so you get what you want on the page. So it shows up like this, and it'll escape this stuff for you. The way to do that, well, is actually you don't have to do the escaping yourself, thankfully. Instead, you can first clear all the HTML. So there's no HTML anymore in any of our elements. We removed all other elements, and what I'm going to do, all elements in our collection now have no other elements inside of them. And then I'm going to loop through every element in the collection that now has no HTML. And I'm going to create a document element, or a text node. I'm going to create a text node with the text that people passed in. And this takes care of doing all of the escaping for you. And then I'm going to append that to the element. So if the element was an li, we had like 3 LIs. We're first removing all of any content or text nodes or any inner elements to any of those LIs. We're removing them all, and then we're going through each one, creating a text node for each one, and appending that as the only child of each element. So it looks like Alexis has dropped out, but I'm going to ask myself a rhetorical question that is really useful. Why can't I simply do this? You might be wondering, why can't you just create the text node once and then append it multiple times to different elements? The DOM only allows an element to be in the DOM in one place. So that's why you can't do it. You need a different text node that needs to be a child of every other text node. So that's why you need to create it inside this loop. It's a very common question for this training. Okay. So with that, we should be able to set everything. It looks like the tests don't really change, but we will get. Now we need to get all text node, all text inside of the elements in this collection, or actually this is the setting. I actually, so sorry. For the getting, we're in the getter. To implement this, we need to get the first element's text nodes and add them all to accumulator, and any child normal elements, we need to recursively get their text nodes and add them to the same accumulator. So to do this, I'm going to create a helper function called getText. And what I'm going to do is return the result of that. I'm going to create a getText helper, which I'm going to implement in a second. I'm going to pass it the first element in the collection. So this is going to take the first item, the first LI, and get its text and return that. And it's going to do all this recursion. So let's take a look at how to implement getText. So I'm going to create my getText function. It's going to take an element, and it's going to create all the text. It's going to create an accumulator. This just means a variable that contains all of the text that we're adding to. And then I'm going to loop through all of the child nodes of the element. So I'm going to loop through each element.child nodes. Child node contains all of the direct children of elements. And then I'm going to get each element, each child, and I'm going to check if the child node type is 3. So you can check if an element, what type of element it is. It has a special node type property, and it's 3 if it's a text node. If it is a text node, I'm going to add text. I'm going to add to text the child's node value. Otherwise, if it's not a text node, in this case, I'm just going to assume it's a normal node. And I'm going to recursively add, I'm going to call getText with that child, which should get the text of all that child, and I'm going to add that result to the text. So this is like recursion. Recursion means you have a function that ends up calling itself. And then eventually, I'm going to return the text. So with this, my text should run, but it did not like a pen child. What did I do wrong here? Oh, I try to append something to itself. Run it. Now my text passes. So to recap, because this one is a little bit harder and more confusing, the setter works by removing, let's imagine my collection is a bunch of LIs. The setter works by clearing out all of my LIs child nodes, and then it goes through each LI, creates a text node for it, which does that escaping, and then appends that text node as the single child of each element. The getter works, and again, jQuery's getters always get the value for the first element. It works by calling this recursive function with the first LI. And that recursive function is going to go through all of that LI's child nodes, or in this case, the UL. If we were doing it with the UL, it would go through all 7 of those child nodes, and it would look at each one and say, hey, if you're a text node, well, add your text to this accumulating text. Otherwise, go get the text of your child LI, and then add that to text as well, and then return all of those summed up. So I think that's the last exercise for today. Oh, I think we're going to do from. We do this one too. We do find as well. So actually, I take it back. One more fun one that I'm going to do quick. This is the find method we're going to implement. So that allows you to go from one element and get other selected nodes that are its child nodes, or like recursively through all of its child nodes, anything in there. Fortunately, the DOM makes this easier for us. The DOM, those same methods that allow you to search from the document to find child nodes, you can actually search from any other element to find child nodes that match certain criteria. For instance, if we found a breeds element, we can find all anchors that are inside of an LI inside just that one element. This is kind of like contextual. So we find things all in a certain area, but not the document as a whole. So we're going to use that to make a find method that will, given our child elements, or given our root collection, go through every item in that root collection and find things that match this CSS selector in every element of this root collection, and return a jQuery collection of that. In order to do that, we need to make it so I can pass $, not only a CSS selector, but something that is array-like. And I'm going to use element query selector all to do this. So I'm going to implement this one really quickly because it's pretty straightforward except for the array part. So to do this, I'm going to create my collection of nodes that we will be adding things to for each element in the collection. So I'm going to go through every item in the collection. For every element in the collection, I want to find the nodes that match this. To nodes here. God. Sorry, we're having a little bit of technical difficulty. I'm not sure what's going on, but I'm going to blame Comcast. Hey, Alexis, are you back? I don't know if Alexis is back, but I definitely think I'm sharing again. So anyways, stepping back, we're implementing this find function that, given a selector, finds all of the descendant children of each item in the collection that match this selector. Okay, I'm back. Good. Okay, so we got to the point where I was going through every element, and I was finding those descendant elements. You blame Comcast, yeah. So I found the descendant elements. Now I need to add them to this list of nodes. I can do that by doing nodes.push, but I want to push in each one of these elements. I can't just unfortunately write elements, because that would push in, make nodes an array of arrays. Instead, I need to have it like kind of a flat list. Now, another way people might sometimes do this is you'll see people doing concat, and they'll have to do it like this way. Because what concat does is it creates a new array every time. And that's not very efficient to always be recreating arrays. Instead, the fastest way if you want to have a bunch of items to be added to an array at one time is using push, but you have to use it, you have to splat those elements. So what that means is I'm going to do push apply. I'm going to pass in nodes because that's what I want it applied to, but I want the elements array here to act as the arguments. So this will add all of those elements to nodes. And then with that, I want to be able to return $ and pass in my nodes. So this is what I want find to look like, right? It goes and just essentially is going to every child original element in the collection, getting all of its descendants that match selector, accumulating them all in this nodes array, and then I want to pass that nodes array to $, which will wrap that, will turn that into a jQuery object. Now, our $ function doesn't currently do that, so I need to check. If selector here is a string, well, I want it to do what it was doing before. Otherwise, I want it to just assume that the selector are the elements that we should be using to create a jQuery collection out of. So to do that, I'm going to create this elements thing here. And what I'm going to do is if type of selector is a string, welcome back, Alexis. If it is a string, then I want elements to be the element selected from the document. Otherwise, I'm going to assume it's an array. I want elements to be the array. Now, if I wanted to clean this up a little bit more, I could do something like else if, is array like selector is array like, then you're going to just assume that it is the elements. But because we don't have really another else case, I'm just going to leave it as the else. Hopefully that makes sense. We're just checking the arguments and doing different things if we get in an array. And with that, we're done. So that's it for this week. Hopefully you have a little bit of context about how jQuery works. So I'll hang out on for a few more minutes if people have questions. Otherwise, Alexis and I will be monitoring the JS training Gitter for anybody's questions while they're working through these exercises. What time is it there, Alexis?
It is 11:43 p.m.
Oh, wow. It's late. So when do you start training? Your training?
Scheduled for Monday, but we'll see how all the scheduling works out. There's still a few logistics being sorted out.
Are you doing this JavaScript training?
Yes, this is part of it. This is part of it.
Awesome. Sorry.
This is a big part of it. This is really, really crucial stuff. If for everybody watching, if you can understand this kind of stuff, the inner workings of a library such as jQuery, this is how you can build open source libraries of your own, or more commonly, utility libraries that you use in your own companies. That's typically what happens. But
Yeah. I think that it's important to understand, I mean, how what you're working on works. Like, you never need to, I don't think you ever need to know it like perfectly well enough to maintain it, or, you know, but you should have a halfway decent understanding. Like, I think the best programmers, you know, have an idea about how, I mean, I don't think you need to go to like quantum mechanics for the transistor level, but I think it's good to know, like, oh, in general, like, how does a circuit work, or how does a chip work, right? So that you can understand, like, oh, well, you know, things are pipelined, but if you have a branching condition, branches can be really, really bad, right? Ifs can actually slow things up quite a bit, because it can flush out. And then how the depth at which you can go, I think, helps you quite a bit, right? From like, okay, I need to build this. Okay, now do I understand jQuery? Do I understand JavaScript? Do I understand how, like, you know, how JavaScript itself is implemented? Do I understand how a processor works? Do I understand, like, how transistor works? Do I understand quantum mechanics? You don't need to get all the way there, but the more of those layers that you can penetrate, I think you're a better programmer, personally. Well, if it doesn't seem like there's any questions, thanks everybody for joining us. Alexis, if you can you edit that connection issues out when you post the video?
yeah, I'll take a look.
Thank you. All right, and then until next time, see you later. Bye.